Hi, welcome to a new series on large language models. There has been several requests to make video explaining how we can build a model and use it for inference and various conversion factors, essentially a complete pipeline utilizing the modern large language model technology. Welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we bring you hands-on demonstrations and insights into the latest tools and trends to help you get started with ease. Don't forget to subscribe and be a part of our journey into the future of technology. So in this series, I'm trying to explain this in my way. Okay, so this will be a multi-part series. So in this first part, we will see how we can create a model. The second video, we'll see how we will use it for inference. Then we will learn how we can fine-tune, etc. The speciality of this series is we are going to use very tiny examples. In fact, one sentence, maybe one word, so that we understand the process really well. So our goal is not to build a very sophisticated, expensive, large language model with big corpus data. Our goal is to see the code in action. So in the first video, we are going to see these things. That is, we will have a tiny text file, maybe 2 or 3 sentences, or maybe just one sentence as the input for the model to be trained. Next step in the process is called tokenization. This is actually one-to-one mapping of the input text into numbers. It can be one alphabet, it can be one word, or it can be a portion of a word. What is important is there is one-to-one mapping. For example, if a capital A is 32, that is, if we pass capital A to the tokenizer, tokenizer will give us 32 always. So that is what this is doing. Okay, and then we will convert this into embedding. So these embeddings are again numbers, but they have deep meaning around it. These numbers are called vectors. They are hyperdimensional coordinates depicting the meaning of those tokens. Okay. Then comes the magic. So this is a multi-layer deep neural network which will do the iteration to learn and create weights and biases based on the input text. Finally, we will have model weights. So essentially, we provide some text, it will learn from it, learn the relationship between those tokens and create this as the output. Okay, so we don't need to understand what is happening inside. It is a deep neural network, and so the goal is not to understand what is happening here inside. Goal is to understand this entire process in a nutshell. In the second video, what we are going to do is we will take the user query, convert the query to tokens using the same tokenizer, and then similar embeddings so that the query becomes a set of meaningful vectors. Then we use the transformer model using the weights that we have learned from the previous stage and create the output token ID. And then finally, we decode the tokens back to English text. Okay, so let's look at the code. Okay, so here I have the train.py, which is a Python code. And let's go over the steps. Step 1 is loading the dataset. So in the data folder, I have a tiny corpus.txt. So this is the tiny corpus. So I just say, I love cats. So this is the tiny input using which we are going to train the model. So this part is clear. We are reading the text tiny corpus into this variable text, and this print line is just to show first 200 characters of the text for debugging purpose. Clear? So this thing is clear. Reading the data set. Next is loading the tokenizer and encoding text. So in the first step, we have just read the text as it is. Here we are using GPT-2 tokenizer. We are creating the tokenizer object, and we say we want to return tensors. So here what is happening is converting our input text to tokens. Here, for our understanding, we are printing the tokens. We are also printing the shape, that is the dimension. And then finally, we are also decoding the tokens back to show that these numbers are one-to-one equivalent of the input text. So this much is clear. Next step, we are defining the GPT-2 model, how many layers we need, etc. We don't need to go into the details of it, but this is what is defining the size of the complexity of the model that we are creating. We are creating a very tiny model. Then we are initializing. If you have GPU, we can use it here. I have a Mac M4, but I am using this CPU because I have containerized it. The reason is when I containerize it, anyone can run it, even without a GPU. Then finally, we start the training loop where we go over adjusting the weights and checking the loss, and we are printing the iteration number and the loss. This is called gradient descent. If you have learned machine learning, you will know what it is. So this will find the optimal weights needed for the neural network based on the input data. So here we are only looping 5 times. That is, a gradient descent is only attempting 5 times. Then save the model and tokenizer. So here we are saving the model and the tokenizer. Tokenizer we are saving so that when we infer, we can use the same tokenizer. We are also printing some extra information for us to understand. A few lines from the config.json, and then we print that the model is ready and the model files are in output_model. This is the tiniest demo possible to create a large language model. So let's see how we can run it. The blog article containing the code will be also given in the description so that you can try this yourself. I'm in a folder that has few files. Okay, so this tiny corpus.txt is our input data. Cat data tiny corpus. I love cats. Okay, so that is the smallest data using which we are going to build our large language model. Now, in order to build, all we need to do is docker compose up --build. That will run the train.py code that we just saw. Okay, so it's over. Step 1, loading the data set, and this is the data. I love cats. Step 2, loading the tokenizer and encoding text. So token ID. So after tokenizing, you will notice that I has become a number, love has become a number, and this is cats. So we have 3 numbers. What we will do is we will visit a website to see the tokenized. Okay, so this is the website using which we can check the numbers. So here GPT-2 I have selected. Okay, so GPT-2 we can select because that is what we are using. And here if I take I, you will notice that 40. I love cats. See, 40, 1842, 11875. So that is what we got here. Okay, so essentially converted each input I love cats. I'm going slow here because this part, most of the videos are very complicated for ordinary people like us to understand. So this is one video where I want all of you to understand this really well. So essentially input corpus text is converted to numbers. In this example, they happen to be single letter and single word, but it can be a part of a word also. Okay, but it is always fixed, so that input and output conversion, you will get back the original sentence or original text. So far is clear. Then here we are showing that from these numbers we can anytime get back the original text because they are all corresponding. So 40 will become I, 1842 will become love, 11875 will become. So you can convert the text to tokens and tokens to text, and you will get back the original. So this is just to show that it is possible. Okay, so then the training starts. So this is the epoch loop that we saw, and we are iterating only 5 times. And see this. This is the loss. After first iteration, found that this is the error, 10.6483. For each step, you will notice that the loss is reducing. That is, accuracy is improving. But to showcase this example, this much of epoch is enough. We don't need to spend more time looping. But this is just a demonstration. This model has no other use but to teach us. Okay, then step 5, saving the model tokenizer to output. So these are the files that we will have in the output model folder, and we have the config JSON which has the parameters needed for the model. So if you look at the files in the output model, you will notice that the tensors are the training results are there in the model.save tensors. So remember, this model has 13 million parameters. So that completes the training part. So that is it for this video. So a quick recap. Here we saw how to train and create a model. Essentially, create a model means create the weights and biases for the neural network. And we followed these steps. So subsequent videos, we will also do such tiny example of fine-tuning a model, converting the model to GGUF format, because current format is the HuggingFace format. We will also see how we can convert it into Apple Silicon MLX format, and we will also see how we can use this model within Ollama. So there will be a series of very unique, very precious, very tiny examples like this. So stay tuned. Please remember to like, share and subscribe. See you in the next video. Bye-bye.